Next, we have Ernie Sanchez. Ernie's with a company called Cinnafilm. They do some really complex problem solving. Most of their services have been to other high-end post facilities. Now they are making those products available to everyone, and one of their new systems that I hope you'll talk about too is called PixelStrings, and PixelStrings is in the cloud services, all the things that they've been doing that he'll have to tell you about. But it's a really great way that people can access all these things to fix their problem videos, and I've seen a few of those. So take it away, Ernie. Thank you.
Thank you, Jim. Thank you for joining me on Saturday. Thanks for inviting me. It's great to be here. So you just saw the Avid, which is great stuff. And one of the things about Avid is you created your project. You have your masterpiece. You have what you want to deliver to the world. The question is, what delivery format do you need? That's kind of where Cinnafilm has been for the past 11 years. It's all about format, frame rate conversion, going from taking an asset that the editor did a great job, but it was just 30 seconds too long, but he's on vacation, he's in the Bahamas or something. You got to cut that 30 seconds out. How do you do it without affecting the content? Those type of things. So that's what we've been doing. We've been doing this in an automated fashion. We're all about automation, automation, automation. Intelligence to solve the problems instead of having the users go in and dial levers all the time, because that's a pain in the butt. And I think everyone agrees with that. So there's a lot of stuff on this, but essentially what I want to talk about is we took all of our on-premises technologies, dark energy, tachyon, wormhole, radiant grid, we put them up in the cloud and we made them all available on a pay-by-the-minute of your runtime. So if you have a 1-minute project and you need to do some denoising, you got to do a frame rate conversion because it's going over the pond to Europe for distribution, or you need to create a DCP or an IMF of that, you pay by the running minute of the asset. You don't have to buy the hardware, you don't have to buy the high-end GPUs, you don't have to buy everything that's needed, you just use the platform as a service. I say platform because we have things that plug into it. Skywalker Sound is our audio partner, so that's the folks up in Northern California. They are basically taking all the intellectual property that's been inside Lucasfilm for decades from an audio perspective. They're turning it into a plugin, and it's going into PixelStrings. So audio channel remapping, down conversion, up mix, all sorts of great things that they do within the walls of SkySound is now going to be a plugin inside PixelStrings, which we're very excited about, because audio's equally as important as video. Because if it's not right, boy, you notice audio right off the bat, don't you? I mean, you could put up with a glitch in a frame because it's forgotten, but if the audio is bad from start to finish, it's a miserable experience. So we're really happy to have Skywalker as our partner. So PixelStrings won the HPA Engineering Excellence Award in 2018. Very happy about that last year. How it works in the cloud. Essentially, you're going to take things and you're going to load it up to your AWS bucket if you have one. If not, we have a storage front end on it, and I'll show you what that looks like in just a bit. But that's what you pay is on the side. So it's $2 a minute, $2.50 a minute, $3 a minute. Then if you add cool stuff like the automated Technicolor SDR to HDR upconvert, it's the technology we call Xenon. It's a partnership we have with them, where you get rid of the noise. You do the up conversion from standard dynamic range to high dynamic range. It's a perfect tone map from the lower 100 nit asset up to 2,000 nits, and I'll show you examples of that, but unfortunately, this isn't an HDR projector, so it's going to be washed out. So, but the idea is that the color stays the same. Oranges are orange, reds are reds, yellows are yellows. You don't have to worry about yellows turning green because you pushed it too far, that type of stuff. And those are just upcharges, 50 cents a minute. And then if you want to do an IMF or a DCP package, it's 50 cents per running minute. Now, those are all list price. If you have a lot of bulk, a lot of things you have to get done, the pricing does come down. But again, we're not having you buy all of our expensive on-premises software stack. You're just using it in the cloud. Some of the image processing things that we do, Tachyon. This is used by nearly every content broadcaster and delivery entity out there for essentially frame rate conversion. You just created your asset, it's 2398 or it's 24p. You have to deliver it in 25p, but you don't want your runtime altered. You don't want to have to go back and pitch correct the audio. You put it into Tachyon, will generate 25p. Not by doubling frames, not by blending frames, but by using motion compensated technology to create frames that never existed before, so it plays back at 25 frames per second. We won the Engineering Excellence Award for this in 2014. It's fast. incredibly fast. When you use a current generation GPU, we will do a conversion from 50p to 5994p at over 60 frames per second at a UHD resolution. So you're talking a lot of content that needs to be taken from 24 to 25 or 50 to 60, whatever it is. It gets done incredibly fast and incredibly accurate. Some of the things that are built into this, I mentioned technology, all about having the intelligence. I mentioned intelligence, having the intelligence to do what you have to do to create the right asset, not turn dials and levers and sliders and stuff, but just let the software make the right decision. So for example, if we're taking a 2997i and we want to create 23976 from it, we just don't deinterlace it and then drop frames, because that would be very stuttery and very stroby. It wouldn't be a very pleasing thing to look at a lower frame rate. You have to introduce motion blur, and you have to introduce shutter appropriate motion blur, so that way it plays back smoothly. I have some examples that I'll show you on that. That's all automatic. We sense the video essence is 5994. To get to 23, we're going to do X, Y, and Z. Z is add motion blur. That way it's pleasing to the eye. So this is another kind of one of those, is a torture test that a lot of people throw at Tachyon on a regular basis. It's composited cadence errors. Now, this is a standard def. This is pixel for pixel, what we're dealing with. We just kind of blew it up. And this is a 23976 video essence that has telecine applied. Standard telecine, it's been used for decades. You have 4 frames, you have to put it into 5. So you take the 4 progressive frames, A, B, C, and D, and you pack those frames into the container of the interlaced 2997i. Frame A, B, 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 C, C, D, D, D. Standard telecine. It's been done for years. The problem is that people will shoot at 23976 because they want the filmic look, they want the motion blur, they want the depth of field, they want everything associated with 23976, but the world of broadcast, it's not 2398, it's 2997i. So what do? They telecine it. And then the editors go in and they grab the 23997i because the deliverable is 23997i, not 23976, and then they start editing 23997i. But it's not true 23997i, it's telecined. And you have that pattern that you have to account for. But editors are editors because they're creative, not because they're frame mechanics, right? They're not always thinking about where's the cadence. I can't have that scene cut between the BC and the CD frame. I have to they just put it wherever they want to. So you have busted telecine cadence everywhere. Or in this case, you have the situation where you have a composite where they didn't match the telecine cadence to begin with. So if you look at the guy in the front, he's at the BC frame, whereas everyone in the back is at AA. I'll step through. You have BB in the back, CD in the front. And one thing to look at is look at this mess right in here. You have a progressive image back here, but you have the interlace and you have the combing artifacts that are happening right there. I'll step forward one more. Now this guy is progressive, but the background is all interlaced. Again, standard problem that we deal with every single day. This is why we won the Engineering Excellence Award, because we fix this automatically. And I'll just keep stepping through so you can see this. So we have a couple of settings in Tachyon. One is called inverse telecine, so you just turn that on. And then if you have a situation where you have the compositing errors, you turn on residual combing removal. Think of it as automatic rotoscoping. We'll go in, identify where any residual combing is left after the telecine, inverse telecine, and remove that stuff for you. So this is the result. And pay attention to things like in here where you have that big propensity for combing continue after the pull-down removal. The amount of hours that it would take to do that with a rotoscope, you'd blow your budget, because it's just too labor-intensive to go in and rotoscope every one out of those residual combs. I mentioned about the deinterlacing going from 5994 to 23976. One of the things in Tachyon is the very high-quality 100% vertical resolution deinterlacer. So these, I'm going to show you 5 frames here, and just kind of note where the car stops and starts based on the relative to these signs back here. This is frame 1, frame 2, frame 3, frame 4, frame 5. When we deinterlace, it's not going to generate a 2997p asset. It's going to generate a 5994p asset. Why? Because that's how many images we have. There's frame 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what we call 100% vertical resolution deinterlacing. You give me 2997i, if it's true 5994 fields, I'm going to give you 5994p to work with. But in the world of film, 5994p wouldn't look good. And a lot of technology will just frame drop. They'll drop a ratio of 4:6 to get from 59.94 down to 23.976, and it's very stroby. We don't like that. And so the reason why is because there's not any motion blur. So here's that same section. That's going to be 29.97i, but we've motion compensated, converted it down to 23.976 while putting motion blur in there. And the images, if I played it back in real time, would be smooth at 23.976. So just to show you an equivalent of that, of what it looks like, this is the 59.94p frame, and that's the 23.976 frame. Some of the things to point out is the blur is also added to the camera panning that's going on. That you look at the auto weak sign, it has the blur injected, the Rolex sign, and then also on the tarmac here, you'll see that since the camera is moving from right to left, you'll get the blur in that as well. Again, it's all about taking something that was at a different frame rate and making it usable at the new frame rate. Dark energy is our noise reducer. So basically, it's all about using motion compensated analysis to determine what's noise and what's not. If it's not noise, we want to make sure we extract that detail. There's plugins for NLEs, but what we have found is that when we dedicate everything to the noise reduction, the way we do it, we're a lot more accurate. We don't work with images in the compressed space. Anytime we address an image, whether it's for tachyon or for wormhole or dark energy, everything is in the uncompressed space. And this all typically happens in the transcoding pipeline. You have the file that gets decoded and it gets demuxed and decoded, and in that decoded state, in the uncompressed state, that's when we go to work on it, because you can't deinterlace an image properly, you can't noise reduce an image properly if it's in a compressed container. It's just impossible. What happens when you do that? You get artifacts, you get dulling of images, and it just doesn't look great. This is a 16 millimeter film scan, just a quick side by side. You can take a look at it. This is the dust busting capabilities of dark energy. So you have that big scratch in there, you have dust in different areas. What happens is we do an analysis, we identify where all the different anomalies are, and then we apply a fix to it. This all happens faster than real time. Now we call this about 90% effective with single frame anomalies. We're not going to be 100%, and the reason why is I can't go in and specify, hey, that right there is a piece of dust. Because that's not the idea of our tool set. Our tool set is you need to get rid of the dust. And what do? We identify it, and then we get rid of it. There's this one part right here. You see right here on his arm? We did not remove the dust there, and that's because in an adjacent frame, there's probably another piece of dust right there. And again, single frame anomaly removal. If it appears in more than 2 frames, we think it's image, we don't touch it. We do our best to prevent artifacts in that type of situation. And I have a couple of videos that I'll show you here. I'm going to go and talk over this. Now on the left, that is the standard def image. We're going to up-res this thing to UHD. And then we're also going to do denoise pass on it, which you'll see right here. And we'll let it play through a little bit. The important thing is that we're taking this 2224 pattern, automatically identifying it, ripping it out, getting down to the 23976 video essence, and then we up-res it to UHD. And then we apply our dark energy. You'll see the compression artifacts just disappear when we do that pass. Again, this image originated as standard def, 640 by 486. The next image that you're going to see is another nightmare that we get thrown at us all the time. This is a broken telecine pattern. There's a lot of chrominance noise in it, and of course it's a standard def image. And you'll see how when we play it, we step through, you'll see exactly the problems with it. Again, 100% automated processing. I'm not doing anything to be able to specify you have to do this to this one frame or this to another frame. And you'll see the chrominance noise removal and the noise reduction on that side now. one other video that I'll show. It's kind of a continuation of this. This shows the frame rate conversion from 24 to 25, as well as a couple of other things. HD to UHD upresing. And this, what we did was we just duplicated the frame to be able to play at 25 on one side. But again, the idea is to be able to motion compensate, convert from your 24 to your 25, so you don't alter the runtime of your project. You don't have to speed it up like like has been done for years. And thanks to Disney for letting me show this footage. Okay. Dark energy for transcoders. So we have two versions of dark energy. One is a scene by scene, frame by frame. I can manipulate the grain in individual color channels within 16 frequency ranges to be able to, if it's an A title, it deserves scene by scene, frame by frame treatment. It's just the nature of that. But for people that have 2,000 hours of content that they've got to get through, they're never going to go scene by scene on that. So we have dark energy for transcoders. That's what's inside PixelStrings. Again, it's the same engine, 100% automated. That's basically how it works. The most exciting thing we're doing now is in the dark energy world is dark energy xenon. This is our partnership with Technicolor. We'll take any DCP or SDR asset and create up to a 2000 nit HDR, S-Log3, HDR, HDR10, or HLG asset. And I wish I had a HDR projector on this so you could see the differences like I mentioned before. But let me go and just get to a couple of, one interesting thing here is this SL-HDR1 and SL-HDR2. One of the things that people are wondering is how do we deliver these HDR assets to the home? And do I have to have two channels, one for SDR and one for HDR, or do I just have one channel that has metadata? SL-HDR1 is a mode inside of Xenon that you put metadata inside the file of an SDR stream. So it's 100 nit SDR asset, but it has the metadata for a HDR10 1000 nit display. So if it happens to encounter a display that's capable, it automatically switches to an HDR asset. The other one, SL-HDR2, is similar, where it's an adaptive HDR metadata, where if I've encoded it to, let's say, 2000 nits, and I encounter a display that's only capable of 400 nits, if I don't do something to that asset, that thing is going to be blown out. It's going to be horrible to look at. So what happens is a handshake goes on, and it says, hey, I'm only a 400 nit display. Don't give me a 2000 nit version. Give me a 400 nit version. And the metadata automatically adjusts the video on the fly to adapt to the display. I think that SL-HDR2 is going to be the broadcast standard because broadcasters have no control over the set that the end user is buying. Someone might buy a Hisense HDR television that's capable of 300 nits, where someone might buy a $1,200 LG that's capable of 1,000 nits. You never know what the end user is going to put in. So adaptive metadata in the encode is where it's going to be, and that's standard inside of Dark Energy Xenon with our partnership with Technicolor. So here's a couple of assets. Again, they're going to be blown out, and the most important thing to take away from this is that the color did not change. You have the 100 nit asset on the left, you have the 1000 nit asset on the right. If you look at the colors, they did not change, and that's the most important thing when you're dealing with content that's already been created, is you can't change the artistic intent, and you can't change the color. Otherwise, someone who created that or owns that is going to get ticked off. And so this is incredibly important when we were partnering with Technicolor. Here's another image. One of the hardest things to get right is reds. And I think you'll agree that it was red on the left, and it certainly is red on the right. There's no difference in that. It's brighter, but again, it's getting getting blown out. You just can't quite see it well without it being an HDR monitor. One interesting thing on this particular image, if you look at the little corrugated tube on the left that the telephone receiver is plugged into, can't really tell it's a corrugated tube, but when you look at it on the right, with our upres from high def to UHD, and then you have the processing, you can actually see the corrugates in the metal. Now, I don't know if it's coming through on this, but the idea is bringing out details that just were lost before because it was a 100 nit HD asset versus a 1000 nit UHD asset. I mentioned oranges are orange and reds are reds. The guy on the left certainly is orange, and the guy on the right is certainly red. And that continued through. Again, this is 100% automated. This did not have a colorist go in and try and make the adjustment from 100 nit to 1000 nits. This is let the technology do what it needs to do. The last technology I want to mention is Wormhole, and we won an HP Engineering Excellence Award for that. All about taking an asset and shortening the runtime without affecting content. How do you do that? Well, you can't drop frames, you can't blend frames. You have to just motion compensate new frames so they play faster. How much faster? Up to 50% faster. No one's going to do that. We give you the rope to hang yourself if you want to. So I'm going to end with just two other videos really quick, just to give you an idea of what it does.
It's so easy when you know what you're doing. It's so easy when you know how. It's so easy when you know what you're doing. It's so easy when you're doing it now.
So that's it. If you have any
Like that.